Hi everyone, welcome back to my channel. If you haven't subscribed to my channel, don't forget to do so down there, and don't forget at the end of the video give me a thumbs up or a thumbs down on my video. It's been a little while since I've done a video on my pulse generator. Doing a lot of research. It's been nothing but a huge learning curve for like the last 2 years developing this thing. 3D printing all my parts, the rotor, the coils, making a coil winder. It's been a long 2 years to get this where I'm at right now. And about a week ago, I came up with a solution to all my problems with this pulse generator. The problem with these pulse generators, and there's all but only one guy on the internet right now that is using the same component that I'm using right now. And I'll get to that in a second. Now, the reason for this is the biggest problem with these motors is power loss. Because it is only creating, well, you can see on my system here, it's pulsing about 250 to 300 milliamps. Now the problem is getting that 200 to 300 milliamps of power into the battery. Okay, because it's going through a huge coil, it's going through a lot of circuitry, it's going through a few diodes and a few capacitors. There's going to be power loss. Irregardless, I don't care who you are out there, I don't care how good your coil is, how efficient your system is, there's going to be actually a significant amount of power loss going through your system. You can time it any way you want, it doesn't matter. Your spikes can be high, but by the time it reaches your battery here, you're going to lose a significant amount of current going into the battery. Now, just an example, this battery here, it's a 20 amp hour, 12 volt battery, 20 hour, 5 amp hours. So you can pump up to about 15 volts DC into this with the maximum current going in as 1.5 volts. Okay, so let's keep that in mind right now. So we're going to start on this end. So I'm using this as my battery because I want to know how much current I'm putting into the system. So I got 12.6 volts at 0.77, let's say 75 amps. Okay, now by the time normally you would get to the other end here, you're going to lose about half of that power. Okay, I don't care how good anybody's system is out there, except for this one guy that I found, and I'll probably try to put the link on after I post the video. And he's building these motors actually professionally, selling them for like, to some of them $3,000. But he's the only guy that I know out there that's using this specific component, and I'm going to reveal it for you today. Alright, this is it right here. You can buy them on Amazon. They're called buck converters. It's a step up, step down transformer. So, just an example, I'm going to switch it over here. It's showing coming in on this end of the transformer, or the buck converter, sorry. It's taking in 12.3 volts. And what it does is I can step up that power now, okay, to compensate for the power loss that's going to occur through the system. Okay, because there's going to be power loss. You're going to be powering a fan. You're going to have some diodes there. There's going to be resistance. So there is power loss irregardless. So before it goes into the coil and through the solid state relay at the back there, you can see it there, you have to get that power back up again because you're losing it because of the circuitry. It doesn't have it with only about 300 milliamps or 250 milliamps of current pulsing. It's not enough to get all that power through the charge controller to the battery you're charging here. Okay, so this buck converter is the solution to this problem. Now this cost me, I think it was about $12 or $13 Canadian. All right, so now I'm going to show you how much voltage is actually going into it. I'm putting in 14.8 volts. Now anybody who knows anything about electricity, if you increase voltage you also increase current. Okay, but when you increase this current power up to 14.8 volts, it doesn't affect the amount of draw on my battery very much. So if I had it just set to say 12 volts and a bit, this would be about a half an amp. So bumping it up almost 2 volts from 12 volts up to 14.8 volts, it's only gone up to 0.73 volts. So the draw from your battery is still very minimal. It's less than an amp. So if you have a stack of batteries here, you could run this motor for days on end and still have plenty of power, because of the buck converter is always staying 2 to 3 volts ahead of itself. So now you've eliminated that power loss. So so basically, now that I got the 14.8 volts, it's going through the coil, doing its thing like it normally does, and then goes to my charge controller, and now it's charging this battery. So I'm just going to turn my voltmeter on here to see where it's at right now. Okay, so I'm at 12.66 volts right now. So in another, I would say, now this is the thing with pulse generators. Okay, it's not going to charge a battery in 10 minutes. Okay, anybody who tells you, oh yeah, I can charge a car battery right from dead to 14 volts in 30 minutes or an hour, no, it ain't gonna happen. These are slow chargers. These will take time. So I can get this thing up to about 13.7 volts in probably about 6 hours. And it sounds like a long time, but no, it isn't, because I'm using such a little amount of power to get there. So, and the other thing too is it's going through a solar charge controller. So it's controlling the amount of voltage going into it. It knows what kind of battery it is. It has the logic in there. So this one here is, they call it a gel cell. So it knows it's a gel cell, and now the charge controller knows exactly how to charge this thing properly. And I've also hooked up an amp meter to my charge controller, so I can actually see the pulses that are coming out of this thing that going to the battery. So it's pulsing like really healthy pulses. Like sometimes it's hitting about 300 microamps, which doesn't sound a lot, but over a period of 6 to 8 hours, this thing's gonna be fully charged. Like just by sitting here, it's already gone up 0.2 volts. Almost, yeah, 0.2 volts. It's gonna hit 0.67 soon, and it's going to continue to climb. And this battery can hold 13.7 volts. Now the other good thing about that is this charge controller, I think I'll show you, should be able to see it, maybe not, but this thing is set for 13.7 volts. So the second this thing hits 13.7 volts, it's going to stop charging it and it's going to discharge. So basically, as soon as I get to 13.7 volts, boom, it stops giving this thing power, and it has a method of dissipating that charging that's going on. So it basically shuts off, so you won't overload this battery. So basically that's it. Like, this is the game changer right here, the buck converter. And nobody out there is using it except for this one guy on the internet. He's making these pulse generators professionally, and they're quite amazing systems to take a look at. So I'm going to put the link of his videos at the end of this one. So if you're making your pulse generator and you want a heck of a lot better performance, and it's really going to change how your system's going to operate and the efficiency, is the buck converter. And it's a step up, step down converter, and you can get them on Amazon. They're only like 12 to 15 bucks. So you get one. This one here I think is rated for 2 amps in, and I believe I think it's 5 amps out, I believe. Yeah, if I'm not mistaken. There's different parameters, but as long as you have at least 2 amps to go in, you're good. So right now it's set at 14.8 volts, and the voltage going in from the battery is 12.3 volts. So we've stepped it up almost 3 volts. And that extra 3 volts is going to get its way through the whole system and get it to the charge controller to your battery, and there's going to be no more power loss there. So look, it's already it's already gone up 2 points since we've been talking. So yeah, you leave this for 6-7 hours, boom, this battery is fully charged, ready to go. So I'm going to leave it at that. One other thing I want to address. I have a lot of people asking me, they want the plans to make this. And okay, I have no problem with that. I'm like, all this stuff here is open source. You can get it on YouTube. There's a lot of plans out there. All you have to do is follow them and put it together. But to actually get the actual plans for my system, okay, all these CAD files and everything I did, I've made custom myself. For me to just kind of give it away, I don't know. You don't even need my CAD files to make this. All you need is a wheel. Put some neodymium magnets around it, make yourself a coil, wind the coil up, buy yourself one of these solid state relays, get a reed switch, or what I'm using is a proximity sensor. You can see it right there. Those are for 3D printers. And I wire it into the system. So what I will be doing, I'll put the schematic out there, but for me to give all my CAD files and everything, that's 2 years of development, and you know what? It's kind of a waste of my time to kind of give all that stuff out for free. So it's like, all you really need is the circuit. And if you get the circuit diagram, how to put it together, all you have to do is use your own ingenuity to build it. Because like when I first started making these, I was using a what do you call, a lawnmower wheel, literally a lawnmower wheel, and I stuck some magnets around the darn thing, and I made it work. So for me to start giving all these plans away and everything, fine, I'll give the schematic away of how this thing is wired up, but I'm not there to build it for you. You have to use your own mind and create this stuff and put it together. I have no problems giving the plans out for it, but to get it exactly the way I have it, you have to use some of your own ingenuity to do this. So I'll leave it at that. But the thing is, like, I've been working at this for 2 years to get it like this. It's a lot of many hours, and also a lot of design work I did in Fusion to create all these parts, made it custom. Maybe someday, maybe I'll start selling them like this other guy is, and his units are like $3,000 and $4,000. I won't sell it for anywhere near that, but there's a lot of development that goes into this. Like, I've spent hundreds and hundreds of hours trying things, changing stuff, try this, try that. It's a trial and error process to get this done. So, if you want this system, you have to put some time into it to build it, because no two machines out there are the same. There's different ideas, different combinations, different layouts. Some people use bigger capacitors, some use other capacitors, some people use different relays, some use MOSFETs. There's so many different combinations out there. All you have to do is get the basic motor set up, and then you start from there, and then you start modifying it. Just get plans that are out there right now, and there's lots of them. Like, I could put my own out. It won't really make much difference because they're pretty much the same as anybody else's pulse motor. It all works on the same principle, but it's a matter of choosing components like the buck converter that's going to make all the difference to make this thing run better. Like, as you can see with this thing, I don't know if you can hear it, this thing makes very little noise. It's quiet. So it's just a trial and error. It took me 2 years of work to get to this. So, be creative. Try something new. Try something different that I haven't done. Right now I seem to have something that seems to be working pretty good. Like, look, my voltage is going up still. So I give this another 2, 3 hours, 4 hours, whatever. This thing's going to be past 13 volts. And it's going to continue to charge. So as far as I can tell, this system does work. There is something behind it. The back EMF pulses, you can see them right there. They're hitting like almost 300 milliamp spikes. And that's going right into the battery. So, like I said, just get your hands dirty and start putting something together. Like I told you before, I grabbed a freaking lawnmower wheel and threw it on a shaft and stuck some magnets around it, and I made it work. So, like me, I have 3D printers. I have the tools to make this stuff. So if you have a 3D printer at home, get AutoCAD Fusion and start designing your parts and print them off. And then you can have a nice looking system like this. I got faceplate here, I designed myself. The rotor I designed myself with the 6 neodymium magnets around it. The coil, everything here you see in plastic, I printed and I designed it myself from scratch. So if you don't have that skill to do that, find somebody that can do it, or try to get off the shelf parts like a lawnmower wheel. Get that, get a piece of masonite board, stick everything on the masonite board. I had metal frameworks that for 3D printers, I put them into a little rig, and I was able to set up a pulse motor that way. You know, you use your creativity. That's part of creating something like this. I've been doing this for 2 years now just to get to this point. And now I've got a system. It's in a carrying case. I can take this thing anywhere I want. It's all concealed. It's got all the components, got the wiring, harnesses. All you need is a car battery to make it run. And the battery you want to charge on this side, hook it up, boom. Flip a couple of switches, you're charging. So I'm going to leave it at that. And any comments, questions, whatever, leave them below there. And give me a thumbs up if you like the video. If you don't like it, give me a thumbs down. And hopefully soon I can get my schematic written up and I can get it posted somehow. I don't know if I'm going to either do a video and just show you the schematic on paper, but I think I've already done it. But I'll do another one, try to make it look a little bit more professional, and then I can go over it so people understand what I actually have written down. So anyways, that's it for the video. Leave your questions, comments, everything, and we'll see you in the next video. Take care.